Hello everyone, welcome back to my channel. And today topic is quantum computing and Ethereum security. This topic is confusing of most of the people and even developers. And then confusing creates here. The quantum computers will break Ethereum tomorrow. So other thing, quantum computing is just a hype and it will never work. Both statements are the lazy. The real answer is more muted, more interesting, and the more technical. In this video, we understand what quantum computers actually do, what cryptographic systems are threatened, why Ethereum is not broken today, and why migrations is inevitable. So the part one is the quantum basics. Before we start all together, then we understand what is the quantum basics. There is a classical bits and the qubits. Let's start with something familiar. So classical computers, how everything works today. That is all are about the classical computers. Every classical computers works using the bits. A bit is extremely simple. The is bit is either a 0 or it 1. There is a no in between that. All computation it's built on this, the Boolean logics and or not, deterministic educations. And deterministic means like if you run the same program at the same input, you will get always be the same output. This applies on your laptops, phones, cloud servers, Ethereum nodes. Everything classical behaves this way. Now we enter about the quantum computing. Quantum computers do not replace bits with the better bits. They use a completely different object, qubit. The qubit is not just a 0 or 1. The qubit leaves a continuous mathematical space. This has drawn as a sphere and it's a Bloch sphere. So at the end of the moment, qubit state can be written as like that way, is this way. So it's a alpha 0 and the beta 1. This does not mean the qubit is both 0 and the 1 in the classical sense. It means the qubit has a state vector. The state is described by the two numbers alpha and beta. These numbers called probability amplitudes. Amplitude versus probability, what is that like? A difference in them. So this is the one of the most misunderstood idea. Alpha and beta are not probabilities. Only after measurement do we get probabilities. Probability of 0 is equal to alpha square, or probability of 1 is equal to beta square, and this must be add up a 1. Like here is also 0 and this 1. So before measurement, the system is not closing outcome, it evolving mathematically. So why this is very important? A qubit state does not mean multiple programs running in parallel, trying all possibilities at once. Quantum computers are not brute force machines. If they are, a cryptography would already dead. So this is not a computational parallelism, and amplitude not equal to probability. So until the measurement, and state presentations not equal to multiple executions. So the second is like a superposition without BS. So you have probably heard the phrase, a qubit is of both 0 and the 1 at the same time. This phrase is popular because it sounds cool. It's also misleading, but what are the superposition really means? Superpositions means the system is the weighted state, not a multiple classical states. This of it like a wave, not a switch. There is no hidden parallel universe trying different value. So real power of interference is like a real power computer. Quantum computer is interference. Quantum algorithms are carefully designed so that wrong answers cancel each other out. So correct answer reinforce each other. This called the destructive interference, constructive interference, and this is why the sentence matter. Quantum algorithms are interference machines, not brute force engines. Without interference, quantum computers are useless. And why this matter? So cryptographic problems are mathematical problems. Some of them have structure that allow interference-based shortcuts. Others do not have that shortcuts. This distinction is why only some cryptography is vulnerable. The third is entanglement. Weird but not a magic. Now let's talk about the entanglement. Entanglement happens when the multiple qubits shares a single joint state. This means you cannot describe the qubit independently. When entanglement is correctness at the quantum level. If you measure one qubit, then the result tells you the something about the other. What entanglement is not? Entanglement does not mean control, communication faster than the light signals. You cannot use entanglement to the send messages, hack system remotely, break physics. The the randomness remains. Why entanglement actually matters? So a lot of people hear what entanglement and immediately imagine something supernatural. So they think that is a qubit are entangles. They can attackers they can attackers somehow get unlimited power, as if measuring one qubit gives a direct control over another one far away. That idea is completely wrong. Entanglement does not mean control, it does not mean communication, and it absolutely does not mean instant hacking. What entanglement really means is corrections. When two qubits are entangled, they share the single mathematical state. You cannot describe the one qubit without also describing two other. But here is the crucial part. When you measure a one qubit, you do not get a choose the outcome. The result is still random is there. The only thing entanglement guarantees is the outcomes is related, not that they are controllable. This is why entanglement cannot be used to send messages, break encryptions directly, or bypass cryptographic rules. So when people say quantum entanglement gives a god-like power, this is the hype, not physics. Entanglement is a mathematical relationship, not magic channel. So the fourth one is measurement collapse, where quantum power breaks easily. So now let's talk about measurement, because this is the quantum computing becomes fragile. Before any measurement happens, qubit evolves smoothly. The probability amplitudes change, interface happens, and this is the where the quantum advantages lies. But the moment you measure a qubit, everything change. Measurement forces the system to choose a one classical outcomes. The wave like a quantum state collapse, all over the possibilities disappear instantly. After measurement, there is a no quantum information left. You cannot rewind it, you cannot inspect it again. This is the incredibility important. In classical computing, you can inspect memory as many times as you want. In quantum computing, looking and destroy the information. So why the measurement collapse matter attacks? So this is the why quantum attacks are extremely hard to execute. A quantum attackers cannot safety pick intermediate result. They cannot test partial guesses. They cannot debug the way classical attackers do. The attackers make a mistake in the quantum circuit. The information collapse and it's gone. That that means quantum attacks must be mathematically perfect, must be engineered extremely carefully, have have no room for the trial and error. So yes, quantum computers are powerful, but they are also fragile. Quantum advantages comes with a very high cost. So the next one is the quantum is not equal to faster computer. So let's kill the biggest myth completely. Quantum computers are not faster version than your laptop. They will not replace GPUs. They not replace CPUs. They will not replace the Ethereum nodes. They will not make a browser faster, speed up your databases, execute smart contract faster, reduce gas fees. Quantum computers are not general purpose machines. They are specialized math accelerators. They only provide a speed up for the very specific problem types. Factorizations, distinct logarithms, certain search problems. If problem does not have a quantum algorithm designed for it, the quantum computers gives the zero advantages. This is why the specific cryptographic systems are threatened. Our part 2 is like why cryptography exists at all. What computationally infeasibles really means. So, like modern cryptography built on the core idea asymmetry. Some computations are easy to do in a one directions but insanely hard to reverse. For example, like multiplying a too large number in easy. Factoring the result back into the original numbers is extremely hard. When cryptography say impossible, they don't mean mathematically impossible. They mean impossible with the realistic time frame. Even if you used all computers on the earth running for the billion of years, attacker would still not finish. This is the what computationally infeasible actually means. So the blockchain security is economic, not a secret. So the codes is hidden, the algorithms are secret. In fact, everything is public. They are secure because attacking them cost more than it's worth. There is economic security. If breaking a wallet costs electricity, hardware, and time, then the wallet contains the system is secure. Quantum computing threatens this balance for the some cryptographic systems. Like three types of cryptography is there. So first one is a symmetric cryptography. Okay. In symmetric cryptography, the same key is used for the encryptions and decryptions. A classic example of AES. If you if you have the key, you can decrypt the data. If you don't, then you can't decrypt the data. Security depends purely on the key length. So if quantum computers weaken symmetric cryptography, the solution is simple. We increase the key size. And that's why the AES 256 is still considered safe. There is asymmetric cryptography. Is asymmetric cryptography works differently. Here you have like public key and the private key. The public key is shared with the world, and the private key must be never revealed. Example like RSA, ECDSA, Diffie-Hellman. Security depends on hard mathematical problems, not a key secrecy. Ethereum wallets depends directly on this cryptography. This is where the real risk lives. And the one is the hash functions. The hash function are only the way of functions. They take input data and compress it into the fixed size output. They are easy to compute and extremely hard to reverse. Ethereum uses a Ketchup 256 everywhere for the addresses, state, transactions, block structures. Hashes affected by the quantum computing by they are not broken. Then the part 3 and the important one, quantum algorithms that actually matters. So there are two quantum algorithms. Shor algorithm, there is a real threat. Shor algorithm is the reason that quantum computing matters for Ethereum. Discovered that in 1994, it solves that in integer factorization, this create a logarithms, so can be solved efficiently on the large enough quantum computers. These problems are the foundation of the RSA, DSA, RSA, ECDSA, and Diffie-Hellman. If this problem for public key cryptography false. So Ethereum impact explain Ethereum impact how that Ethereum impact like Ethereum externally owned accounts used by ECDSA. ECDSA works because deriving the private key from the public key is infeasible today. Shor algorithm removes that assumptions. If the quantum computers is powerful enough, then public key to private key becomes computable. That means the wallet security collapse. So that how actually attack would work. So first a user send a transactions. When that happens, the public key becomes visible on chain. A quantum attackers observes the transactions and they run a Shor algorithm on a public key. If successful, they recover the private key, and with the private key, they can forge the valid signature, and the network cannot tell the difference about the signatures. So the important nuisance or important safety window. If attacks only works after a public key is exposed. So if address has never spent funds, its public key is not visible. It is a safer for now, but the moment it transact, that risk exists. So there is also the Grover algorithm. Why it is not a killer? So Grover algorithms speed up the brute force searches. It reduces security by the square root. So the 2 raised to 256 become 2 raised to 128. That is a still astronomically astronomically large. Hashes survive with that. Symmetric cryptography also survive, and public key cryptography does not, because Grover doesn't fix Shor. So here there's some quantum impact summary table also. The crypto systems is RSA, ECDSA, These all are the systems or like different algorithm we use for the secure the passwords, keys like that. So that use for the TLS legacy system, that for Ethereum wallet, key exchanges, hashing, Ethereum hashing, symmetric crypto, and quantum impact broken by Shor. That broken by Shor, that broken by Grover, and that weakened also. That not crack or that not broken, that weak and must be migrate. The broken so that must be migrate the status and the long term risk. They both have a long term risk, not a short term. Like in the short time, they don't expose anywhere. And these all are safe. and this safe with a margin. So what is the every broken system is public key cryptography. This is not a coincidence. Part 4 is what is means Ethereum. Ethereum reality check. Like Ethereum is not broken today. Current quantum computers are too small, too noisy, too unstable. They are not run store algorithm at a scale needed. But cryptographic migration is unavoidable. So this is not a panic, this is a planning. Ethereum is already prepared or already planning. Ethereum research focused on the account abstractions, crypto agility, post quantum signatures, hybrid schemes that combine classical and the post quantum security. Agility means the system can upgrade cryptography without rewriting Ethereum from scratch. So the final takeaway is, so let's end with the clarity, not the fear. Quantum computing is real, it is advancing, and yes, it eventually changed cryptography. But Ethereum is not broken today, and there is no quantum computer right now that can steal your ETH, forge your signature, or crack your wallets. Anyone saying that is just selling panic, not fact. At the same time, pretending this problem doesn't exist, that also wrong. Blockchain are built on the last for the decades. So quantum computing is not maybe technology. It is a when, not an if. And that means cryptography cannot be static. The real lesson from this video is not quantum will destroy Ethereum. The real lesson is Ethereum must be able to evolve cryptographically. Security in blockchain has never been about having an unbreakable math forever. It has always been about staying ahead from the attackers by upgrading faster than they can. Ethereum must be able to evolve cryptographically. Security in blockchains has never been about having unbreakable myth forever. It has always been about staying ahead of attackers by upgrading faster than they can. That's why hashes can be replaced, signature schemes can change, wallets are evolved, protocols can migrate. This is not a weakness, this is the good engineering. So the future Ethereum is not a panic. The future is crypto agility, careful migrations, and long-term thinking. Quantum computing doesn't end Ethereum, it forces Ethereum to grow up. So here's our quantum computing versus Ethereum's topic is over. And if you want to, then we will go deeper on the how Ethereum is preparing the post-quantum wallets look like and what changes will matter in the real systems. That things we will discover in the next video. So till that, goodbye everyone.